Great. Oh, and the recording's in progress. So thanks for having me, and thank you, Ashley, for introducing. I'm also going to share my slides to everyone in the chat so that it's available for everyone. So welcome and thank you. My name is CJ. I am a research associate with the World Data System International Technology Office in British Columbia, Canada. I'm actually calling in from Ontario, Canada, so there's a slight time difference there. And I'm going to be speaking on behalf of the Research Data Alliance Global Open Research Commons International Model Working Group. It's not just my work, it's actually a host of people that went into this. So my talk today is really about the Global Open Research Commons and the model that we created for improved interoperability and collaboration. So the first thing to talk about is what actually is a Global Open Research Commons, or what we've been calling a GORC. So Open Science Commons or Data Commons, there's other words that go in there, provide a shared virtual space, platform, and or marketplace for data and services, as well as other types of research objects. And examples of these kinds of things include the European Open Science Cloud, the Australian Research Data Commons, the African Open Science Platform, as well as government portals and initiatives outside of traditional research contexts. Coordinating across these initiatives to enable a network of interoperable research commons is the goal of the GORC. And so our realized vision of GORC will be to provide frictionless access to all research artifacts to everyone, everywhere, at all times, with the appropriate infrastructure protocols and support. So we are considering that not everything can be fully open, kind of in the same way that fair doesn't mean open. And that's why we also emphasize that there's infrastructure support and protocols in place for this too. The first part of this is the GORC interest group within the Research Data Alliance. And so this group provides a neutral space where people have conversations about open research commons. The interest group is working to develop a roadmap, which is what this little map-like thing looks like here, towards global alignment to help set priorities for commons development and integration. And so part of their work was to actually define what is a commons. And what they kind of settled on was a global trusted ecosystem that provides seamless access to high quality interoperable research outputs and services. The bottom line being a digital research resources for the common good. And if you see your own self or your projects or your organization reflected in that, but you maybe don't identify with the word commons, that's okay, because a commons can be an amalgamation or aggregation or puzzle piece together, jigsaw-ish, of different things too. So a commons doesn't have to be one thing only. It can be a lot of different things put together. So under the interest group is the working group, which is who I'm representing today. And the working group operated under that umbrella of the interest group. So our goal was to evaluate and recommend a model for attributes for global research commons that allowed researchers and developers to coordinate services and create roadmaps for international interoperability. In its current format, the working group aims to answer the what do you need when you're building, expanding, operating, et cetera, a commons or research infrastructure that's looking towards interoperability in the first place. And so the model is a contribution to the roadmap, which will then determine the how do you get towards that international interoperability. And the roadmap will then feed into this global alignment that we're aiming for. So the model is operational on the level of an individual organization or a project or a commons. The roadmap is operational on like a global international field. So the model was intended to be and is intended to be non-prescriptive. It's a guide for you to consider as you build, expand, and operate your commons or research infrastructure with specific intent towards global interoperability. But we didn't just make it up. So the first thing, or part of what we did, was to do a landscape review in two phases, actually, from the Research Data Alliance as well as the digital research infrastructure community. And we reviewed over 150 sources, publications, groups, working group outputs, you name it. This also included things like from the NIH and NIST RDAP. So we tried to be as international as possible, but there were a lot of models that went into the model itself. We also heard from 12 speakers in a speaker series, where we heard from commons from all over the world and what they were currently doing, what they wanted to do, and their own perspectives on how to get to global interoperability. Two of these things fed into the model itself. And so currently it's a spreadsheet which contains entities mapped between essential elements, categories, and subcategories that each have characteristics, such as attributes and features. And so each item in the model, an entity or a characteristic, has an extended description, examples, as well as a list of where we created it from. and of which there is usually a lot. We also have a consideration level to help determine what you might want to consider first as you're implementing the model. The model was iteratively refined, and both within our working group and the wider community through RDA plenary sessions, through an 8-hour workshop we had at one of these sessions, which was really intense, 26 meetings over the course of 2 years with our 69 working group members. It's actually a few more now. And with specifically the work of 6 dedicated task groups that worked on thematic aspects of the model. So the model is organized based on essential elements that were identified by the GORC interest group. And within these essential elements, we've identified about 400 items within them that actually comprise the model itself. So what we are thinking with the commons is that they should have something within each of these essential elements, but other types of research infrastructures like libraries and repositories or institutional repositories, what have you, you might not fit everything in every single element. Maybe you only identify with a few of them, and that's completely okay. The point is that you consider things from the model and map it to your own context and say, what's important for me to include or consider? So the first part of this are the human elements, which are highlighted in white, and they apply to the governance or policy aspects. The first one here is governance and leadership, which is focused on defining organizations' purpose, development of strategies, objectives, values, and policies that frame how that purpose will be pursued by management and internal personnel. So this includes things like strategic plans, policies, guidelines for financial and operational matters, the creation and maintenance of governance structures, their interactions with stakeholders, and the ways of working within management. Rules of participation and access refer to policies that define rights, obligations, and accountability of common stakeholders, how they interact together and with the commons, as well as who belongs to what stakeholder group. Sustainability includes models and agreements made on how to ensure the viability and operations of a commons. And so it includes things, of course, like funding and resourcing activities to ensure that the commons continues to be sustained over the long term, but also things like strategies for sustainability for operations and holdings like transition plans, building and maintaining community trust, as well as keeping issues of sustainability in mind when building in components. Engagement refers to interactions between the commons and the commons community of stakeholders. So engagement activity is seen as an iterative cycle in our model, which includes requirements gathering exercises, consultations, usability testing, communications, and events. A core attribute in this particular essential element is the efficient and effective engagement plan to address community input and feedback. So engagement addresses things like active promotion of participation in the commons by the stakeholders, incentivizing people to participate in the commons, encouraging interoperability with other commons, research institutions, and of course, potential partners. Human capacity is the ability of commons to create a human-friendly environment for all stakeholders and community members in all aspects, so that the commons can set and achieve objectives, perform functions, solve problems, and continue to develop the means and conditions required to do so. So this includes efforts towards building internal capacity, ensuring the accessibility of skills and requirements for planning, managing and assessing service delivery, making clear the skill requirements for the commons community to engage with the commons, increasing the ease of use for stakeholders, and addressing these categories through training and education for all stakeholder groups. In the center of this diagram is a dark blue hexagon representing 2 essential elements technically. One is interoperability and the other one is standards. And even though these are kind of combined and squished together in the diagram, they are 2 different essential elements, but them being together and in the center is kind of highlighting the fact that they're at the core of our research infrastructures and our commons more specifically, and that they actually belong to both human elements and technical elements. So interoperability for us is the ability of data or other research objects, as well as tools from non-cooperating sources to integrate or work together with minimal effort. And so interoperability enables cross-commons reuse of data and research objects and is of central importance. And this encompasses things like technical, syntactic, semantic, pragmatic, and legal interoperability. A standard, on the other hand, in a different vein, is a repeatable, harmonized, and agreed and documented way of doing something. And you can have formal standards, which are maybe to do with the law in your area or are formally recognized by a body like the ISO, but they could also be informal, what we're calling conventions. And so conventions arise when they become part of the accepted way of doing things within a community. So for the data commons context or the research commons context that we're specifying, standards and conventions can address things like research objects, like semantic objects and metadata too, applications, software services and tools, quality and guidelines, persistent identifiers, authentication and authorization, catalogs of digital objects, workflows, plans, mechanisms, and infrastructure, and regulatory and ethical compliance. These bottom three elements are technical items that relate to infrastructure and technology. So the first one that I've highlighted here is ICT infrastructure, which is the hardware and base software components that are required for a commons to function. And they include, on the high level, network, compute, storage, and authentication and authorization infrastructure. Services and tools is also kind of bunched together as one thing, where a service is something that a person invokes, but it's kind of done by software, and a tool is something that a human might use directly. And services and tools can cover things like direct research tasks, workflows and middleware, persistent identifiers, management, security and identification, help desk, as well as a commons catalog of services and tools. Last but not least are the research objects themselves. And because we kind of drew a boundary around, we only want to consider digital work for the commons in this case, we didn't include physical research objects. So within the digital scope, we considered things like publications and research documentation, research data, research software, semantic objects, and collections of these things. One thing that's also available in the model that's kind of outside these essential elements are a list of key performance indicators and metrics that can be used. So key performance indicators or KPIs are qualitative or quantitative measures, and metrics in our case were specifically quantitative measures. So the broad themes that we identified were commons governance and policy, commons engagement with stakeholders, feedback and satisfaction of stakeholders, infrastructure and technology use, and stakeholder engagement with that technology and infrastructure. So our model is intended to help navigate implementing open research practices for your commons or research infrastructure by guiding you through considerations on what to include. So the elements are the main themes, and then within each essential element are lots of items where you can dive in. This field is evolving, so the typology and the framework that we built this on will change, and we already have plans in place to develop the model more. So how do you actually use the model? There's lots of different ways that you can use it. And we've seen lots of people adopt it in different ways, from structuring their funding proposals for brand new infrastructures to working on federated infrastructures and helping them bring those things together to make them more interoperable. But we do have some common themes throughout those uses. The first thing we've noticed is you should start at the top. So start with those 9 essential elements, identify what are some areas of priority for you, and then drill down as needed. Once you have a good idea, feeling of what you want to work on, you can then dive further into the model. We found that when you're having governance conversations like with a board, it helps to stay at that essential element level. But if you're talking with your technical team or your management, it might help to dive down into those specific examples and items. As you do that drilling down process, you can map your existing projects onto the essential elements or the model itself to see where are your gaps or what are you doing really well in. And finally, the model is intended as a guide and can be used for self-assessment to benchmark your organization's progress. From the mapping of your current projects, you can identify what is and isn't addressed. And not every commons or research infrastructure really should be aiming to have something in everything. You want to have something in every essential element, especially if you're on a larger commons-like scale, but you don't need everything in the model. The model is a comprehensive set of considerations, and it's not expected that you do everything. It is important to note that it's not intended for comparison between research infrastructures either. So there's no benefit in saying this one's better than this other infrastructure. What this is trying to do is give you an idea of identifying what's important for you in your context, with your community, with the budget and infrastructure you have available. We are working on other visual representations of the model, but what we do have for adoption purposes is an adoption tool as a Google Sheet, which is available in the slides. You can copy it or download it and then use, as well as a semantic object for referencing the vocabulary, because one of our main goals was to provide a common language to increase interoperability between commons that actually want to interoperate. And so identifying what you're already accomplishing or want to accomplish within the model can help you communicate that to your community as well as international partners. And lastly, there's future work in this. As I said, we're continuing to work on it. The interest group is ongoing towards saying the how do you actually implement the model. The working group is going into maintenance mode, but we're working with our adopters to inform future versions of the model. And we've got some new working groups being ramped up to address specific issues with the model or things that we want to see. So health research profiling, as well as a maturity model, so that it's not a binary, yes, we have this, or no, we don't. And lastly, I encourage you to join our groups to keep up to date on everything, or contact me directly if you'd like to know more. And thanks for being here.
Thank you so very much, CJ, for your presentation. So we're just going to keep moving right along. And yes, if you have questions as they come in, if you have questions, please put them in the Q&A and we'll address them at the end. So next we have Alex May and Shannon Sheridan with their presentation, Bridging the Boundaries of Data Curation Across the DOE National Laboratory Complex.
Thank you so much. My name is Alex May. I am a data curator here at Oak Ridge National Laboratory. I'm here with Shannon Sheridan, my wonderful colleague from Pacific Northwest National Library. She's a research data librarian. And for those that don't know, I'm sure you all know about the labs, but just a quick word about them just in case. There's 17 national labs right now, and they resulted from the US government investment in scientific research during World War II, and today are pursuing a whole range of research agendas. Each of these labs have kind of specific needs, which pose significant territorial challenges. For instance, here at Oak Ridge, we currently have the world's fastest supercomputer. It's an exascale machine. It's capable of a quintillion, I always mispronounce that word, a quintillion operations per second. So you can imagine when I talk about big data, I'm talking about petabyte, terabyte sized data sets, 175 million lines of login nodes that need to be curated. And these kind of create sort of issues that Shannon and I had begun talking about at another conference, that maybe we wanted to get together and sort of bridge the boundaries between the labs and start kind of having this larger group to talk about. So next slide, please. So this is just a disclaimer and acknowledgements, but I think this is actually really important because if you actually take a quick look at this, you're going to realize there was a great RDAP presentation a while back from McGill University about there's no I in RDM. There is just no I. Like, this is a bunch of people that came together, a bunch of labs that came together. Really, it was a ground up group effort. And as a result, it's really kind of a collaborative group. And next slide kind of gets to who we really are. So we are this collaborative group of professional curators, librarians, information scientists, researchers, and developers who are striving to empower scientists to ethically publish high-quality data. Increasingly, we've been talking about including getting more developers into the group to sort of bridge what Nancy McGovern talks about a lot in MIT Digital Preservation Cohort, sort of that chasm of despair where you have your curators and your information scientists and your librarians on one side, and you have your developers on another side. One of the people that we've kind of identified that we'd like to bring in is sort of HPC specialists, and especially people that are really good with data movement. So I've already identified one of those people, Patrick Widener, who will be joining the group. Currently, the group is now comprised of, we started very humbly with just a small group of us. We are now comprised of, at last look, at up to 41 members representing 10 of the labs. Next slide, please. So the whole point of this is to just sort of address the full life cycle of data. It's a strategic cross-functional decision-making entity. I think a real shout out has to go out that one of the more difficult administrative things that we had to do to figure out first was how all the labs could get together and talk to each other. And the shout out goes to Marion Blake over at PNNL, who set up the Teams channel for us, where we go ahead and we share our ideas. We work asynchronously on a series of objectives that we're going to go through in just a bit. Yeah, next slide. So objective one. So again, the idea in creating this wasn't not just to bring together everyone to talk, but to actually have functional objectives with outputs. Now, some of the outputs we were able to meet, some of the outputs we just didn't meet, and we are still kind of like thinking through like what next steps need to happen. Our first objective was to work with the Office of Science and Technology and Information to come up with a more mature data sharing plan and discovery layer. OSTI, whenever you publish a data set, so for instance, if I publish a data set through Constellation, which is our open data repository, the metadata is sent over to OSTI and you can be found in the DOE Data Explorer. And so one of the questions we began asking was like, what are the minimum metadata requirements that should be requested by the DOE? What is required? What should be optional? Could we use a DCAT as a standard across the labs? Increasingly talking with Drew Hewitt and Natalie Barnett, who led this objective. They're aligning more with DataCite right now. We're putting more stress on using related identifiers to link raw data, analyze data, and publications. And then as eLink 2.0 comes online, we're beginning to do some beta testing there to see what that looks like. And again, Drew Hewitt and Natalie Barnett did a wonderful job of leading this and kind of getting us all set up, I think, really well to take on eLink 2.0. Next slide, please. Objective 2. So this is Katie Knight. Katie Knight is one of the smartest people I know in the world. If you ever get a chance to talk to Katie Knight, you should take that time. The idea is sort of an international portal of ontologies and metadata standards for science. She came up with this idea for another DOE Data Days conference. And the idea there is that she wanted to devise metadata management infrastructure to support FAIR principles, and that there might be an opportunity to build metadata standard repository and integrated tools to facilitate cross-domain and facility optimization of scientific and data management. Now, at another presentation, this was actually pointed out to be much harder than you think. And in fact, I really like this quote that DataCite said, that reaching consent in domain taxonomies and ontologies is hard. I mean, that was just basically what they said. This is further when you think about like sort of automatic metadata extraction. So for instance, one of my colleagues, Tyler Skolazak, wrote an article about this in which in a very narrow domain, they ended up, it was batteries, they ended up not agreeing on what terms they really wanted to use. Nevertheless, Julianne Schneider is the one that's leading this, and we're beginning to kind of come back together, and we're beginning to look at the ontologies and trying to think how we might align them and move them forward for the labs. Next slide, please. Develop a data curator toolkit to help data curators assess data sets when they're too large to curate manually. So this is really getting back to that larger issue of what big data is beginning to look. Again, research and metadata extractors, file type identification. There's all of this sort of stuff is out there, like PII and stuff. The problem is, like, when we talk about the scale of the data. So for instance, I work with a lot of telemetry data coming off of the supercomputer that researchers want to publish for systems improvement. And it turns out that frequently there is PII in there. Legal department requested that I start, I was using my own sort of scripts and stuff, and legal requested, well, why don't you try to use Sperian? So I ended up talking to Sperian, which is a legal resource that looks for PII, and they said even on a cluster, it would take a week for them to get through all 175 million lines. Hannah Hadley in the Data Curation Network's Big Data Interest Group had a really great point that in order to make like a toolkit like this, we should really be focused on very small objectives so that each one would do its one thing and do it well. And I think that's really the direction that we're going to go. Additionally, we're looking towards AI implementations here, although we're also aware of the ethical issues of AI that is coming up quite a bit, especially at our lab right now. And I think with that, I can turn it over to Shannon, who's doing all sorts of amazing stuff.
Or at least presenting on the amazing work that our colleagues are doing too. So the next objective that we're working on is to develop best practices for data management plans across the lab. And this grew out of a project that we were doing at PNNL in terms of turning our internal data management plan tool into a machine actionable data management plan tool. And so under those objectives, I've been working with a really great graduate student who has been tinkering away because I do not have the software development skills to make this happen. But in terms of creating our own machine actionable DMP template at PNNL, then we can share with the other labs. The reason that we're doing something internal is there's a lot of internal mechanisms, especially I know at PNNL and at other labs where they're trying to get tools to talk to each other to make the whole curation process easier. And so we are at version 0.5, as I was informed this week. So we're getting there on the DMP tool. Objective number 5 is to develop best practices for liaison work and training. And Alex kind of alluded to why this was necessary at the beginning of the presentation, where we are all separate entities. We're all run by our own, some of us are run by like the same groups, but we are really independent entities, even though we all fall under the DOE umbrella. And what that means is, in terms of support, we're really kind of on our own, especially those who are working in the data management sector. Like at PNNL, I'm kind of the only data management librarian. And so I know that's the same case for a lot of my colleagues at different labs. But the thing is, the labs are a slightly different, sometimes majorly different environment than major universities, which is where we see a lot of liaison work and tools come from. And so we decided to try to develop lab-wide training materials that can then be adapted to specific issues for labs and sharing them. And we actually will be sharing them like publicly. So if anybody else wants to take them and adopt them, we do have an OSF, which I will show you how to get to it at the end of the presentation. But basically making it easier for us individual practitioners to actually provide resources and information for our local staff. And then here on Objective 6, this is one that Alex actually has been working on a lot lately. So working with some partners at the Data Curation Network to create documentation and primers for curators around issues that we see come up a lot at national labs. So Alex just finished a supercomputer, well, not just finished, it's been finished for a while, at least for us internally, but he created a supercomputer telemetry file primer, which also just finished the DCN peer review process. And it'll be going under the requested changes for it to get published. But our goal is to continue to create these primers that are related to specific issues that we see frequently at national labs that might not come up elsewhere as frequently. And then our last objective, and this one is newer than the other ones, is to create scripts or some sort of short paper to demonstrate how to access various repository metadata to allow for semantic search capabilities using machine learning. And Hannah Collier, one of our other colleagues, and has been working with Oak Ridge's Atmospheric Radiation Measurement Data Center, or ARM, to try to identify a solution to searching metadata vocabularies across repositories. And they did just come out with a short report. I'm not entirely sure if that's totally publicly available yet, but basically they were using a transformer model to compare the NASA Earth Data Repository's Global Change Master Directory keywords, metadata, it's a mouthful, but with ARMS metadata. So you could basically search across both of them and find information that you were looking for. And so she just presented her work to the DCN Big Data Interest Group, which was very exciting. And then last but not least, we are, like I said, we're trying to make a lot of these resources available, not just for our DOE colleagues, but for all of our data management colleagues. And so one of the ways that we're doing that, and I will pop this link in the chat, but we did create a very small little website kind of explaining what the group does as a landing page, but it does link to our OSF where we have things like primers, past presentations, well, there's one primer, and where we will be outputting and sharing our collaborative material. So if you're interested in learning more, seeing who's involved, or seeing what information we have available, you can go to that website. And that's the end of it. I think I hit that right on the timer. So thank you.
Yeah. Actually, you had like another couple minutes left. So actually you're like doing great. So thank you so very much, Alex and Shannon, for that presentation. So now we're going to pivot over to our lightning talks. And so our first lightning talk will be from Madison Golden. And the presentation title is Data Normalization for Interoperability. And then after that, we'll hear from Sarah Valeri with her presentation, An Introduction to the NIH Common Data Elements repository. So I believe Anthony has the video ready to go.
Hello, everyone. Thank you so much for attending this lightning talk today. My name is Madison Golden, and I am a research data librarian at the University of Utah's Marriott Library. Prior to this role, I worked in corporate data governance, and I am excited to share my insights on how normalizing research data can aid in interoperability as part of the Research Data Access and Preservation Conference. Interoperability for research data was defined by the National Library of Medicine as ways in which data is formatted that allows diverse data sets to be merged or aggregated in meaningful ways. It is a key aspect of the FAIR data principles, constituting the I in FAIR. For those unfamiliar, the FAIR principles provide guidance for researchers and curators that ensure all data is findable, accessible, interoperable, and reusable. Based on this quote, the main goal of interoperability is to make a dataset usable in and exchangeable by as many different softwares and systems as possible, in addition to having the potential for a broad spectrum of use cases. Many data management practices aid in interoperability, including metadata standards, standardizing data values, creating thorough documentation, using non-proprietary formats and tools, and standardizing file formats. But today I'll be covering the integral and often overlooked role that dataset and database structure play in achieving interoperability. Before continuing, I will note that this applies only to tabular data, so is not related to other data types like videos, photos, code, or text. Data normalization is the process of writing datasets in accordance with the relational model for databases. Relational databases are an industry standard, and examples include Google Cloud Platform, Amazon Web Service, Microsoft Azure, Oracle DB2, and more. The relational model simply means that data is organized into tables, aka relations, which are made up of columns and rows. Columns and rows create entity relationships between tables with common ID fields. Due to the nature of relationships being created, it is common to use one column as a key field, where the main subject of each row in the table is defined, often in the form of IDs or names. This allows for data to be used in as many contexts as possible by reducing a table to its atomic state, where the data contained in each column of the table is not reliant on other variables in the same table. You can see on screen the way this works to combine the tables and data contained in them in multiple ways. This model can be achieved for any tabular dataset through 3 normalization steps. These steps are typically referred to as the first 3 normal forms, but I will refer to them as steps for the purposes of simplicity in this presentation. Once these steps are complete, key interoperability issues are solved that are not addressed through file format standardization or documentation. This results in high data quality with little redundancy, the ability to use querying languages like SQL and visualization software effectively, integration with APIs, efficient merging and aggregating with different datasets, and a broad use case for the dataset. The first step in data normalization is to divide fields with multiple values. In this example, we can see that the list of employees and their units at each library prevents us from using this table to create effective visualizations and limits the scope of analysis for the dataset. We are also unable to use querying functions in languages like SQL that can provide us with information like counts of employees at each library or the number of employees working in adult services at each location. Creating additional rows so all fields have a single value solves those issues and completes the first step. The second step is to make all rows dependent on the primary key or identifier. In this example, we can see that some of the information, such as details about the employee's position within the library, is not directly related to the library itself. Splitting this table into 2 allows the data to be used and combined with other datasets that are only related to library location or the number of staff working in various units. We are now also able to effectively use querying languages like SQL and other analytic methods with minimal data manipulation errors. The final step is to remove transient dependencies. In this case, the employee's work unit has a transient dependency because it is dependent on which employee is being referenced, which is dependent on the given library. Splitting the table apart again into a total of 3 tables removes the last of the dependencies and results in the optimal model for interoperability because the dataset is able to be related to as many other datasets and use cases as possible. This is also the optimal format for data analysis tools and software that rely on relational models to understand datasets and the relationships between them, not to mention more reliable data quality with limited redundancy in the dataset. To wrap this up, you may save the outputted files as separate CSVs for optimal sharing and reuse. You may also load each table into a relational database if you are intending to integrate the tables with other data. Whichever option you choose here will likely depend on if you are normalizing your data as a curation or fair best practice, or if you are doing so to reuse the data and integrate it with new data. Thank you all again for attending this lightning talk. My contact information is on the screen, and I look forward to answering any questions.
Hi, my name is Sarah Villery, and I'm providing an introduction to the NIH Common Data Elements repository. I'm currently an MLS graduate student at Emporia State University, though my background's in nursing. And I did want to quickly share my acknowledgements and note that this project was supported by the Network of the National Library of Medicine Region 3 Student Development Award, though the content and the views expressed are my own. By the end of this presentation, I really want you to understand what CDEs are, how this repository can be used, why it's relevant for you, and where you can learn more. To begin, I'd first like you to think about how many times you've attended the RDAP Summit. Is this your first time like me? Maybe 2 to 5 times before, or more than 5? Now imagine that RDAP wanted to collect that data from each presentation and asked each speaker to take a poll. The next poll, poll B, may ask a slightly different question with slightly different answers, and a third poll, poll C, may have the audience type in their answers. How could RDAP compare the data gathered from these polls? It would be difficult, time-consuming, and costly. So what if instead the presenters were given a standardized poll with a set question and defined responses? How many times have you attended the RDAP Summit? And the possible replies may be 1 to 2, 3 to 4, or 5 or more. That would make it much easier to ensure consistent data collection, and that's exactly what common data elements do for research. So this Common Data Elements repository was created by the NIH in 2015, and it provides free public access to search and use common data elements. It's a tool to improve the accuracy, consistency, and interoperability among datasets. So the repository can be accessed through the web address cde.nlm.nih.gov/home. And why is this important? Well, first, using CDEs enables easier data sharing, and it adheres to the FAIR data principles to make sure that your data is findable, accessible, interoperable, and reusable. It may also be required for researchers to meet new federal data management and sharing policies, including those from the NIH. But why would researchers want to use CDEs? Ultimately, it's because it improves the quality of their data and it saves them time and resources. Librarians also have an opportunity to be an integral part of the research team and help navigate this process. So these are some of the things that we're already doing or we're equipped to do. For example, we can use our skills in data management and sharing to support researchers, or we can help provide training on using the repository. Now, because I only have 5 minutes, I don't have time to take you through details of the website or a full sample search, but I do want to highlight some of the important features on the homepage to get you started. So the first is that from this homepage, you can browse or keyword search CDEs, forms, which are sets of CDEs that have been bundled together, or NIH endorsed CDEs, which are CDEs that meet criteria established by the NIH, and they're designated with a gold ribbon in the repository. So to browse, you would select either CDEs or forms from the top right banner on the homepage. And for keyword searching, you would use the search bar in the middle of the screen. You can use Boolean operators in the search function. Also, while you can browse, search, and export without signing in, if you do register for a free account, you get access to expanded features. For example, you can save CDEs for later on what's called a board. This slide is showing the browsing CDE page, and from here, I wanted to highlight that there are over 23,000 CDEs available, and you can always refine your results using filters on the left-hand side of the screen. Finally, let's take a quick look at one of the CDEs. For this example, I selected education. So first you see the gold ribbon icon next to the title, meaning this is an NIH endorsed CDE. And at the top of the page, I also see a pin icon where I could pin this to my board to save for later, and export where I could export the CDE for immediate use. I see the standardized question text. In this case, what is the highest level of education you've completed? And the allowable responses, which are listed here as permissible values. So this was an extremely quick overview. If you haven't already, I encourage you to explore the site. And if you're interested in learning more, there are many step-by-step guides and resources available through the database. There's also a highly informative free webinar created by the NLM, and it goes into much more depth about the database and searching strategies. So I've included a QR code here if you're interested in that. Here are my references. And here's my contact information. So please reach out. Thank you.
Okay, thank you so very much, Madison and Sarah, for those presentations. So now we're going to go ahead and open it up for Q&A. So we do have a few questions there already. So, but if you do have any other questions, please drop them in the Q&A. Please make sure to note who it is to, just so I make sure I direct it to the correct person. Excellent. Okay, well, we are officially at time. So please give our presenters a big round of digital applause. Thank you to our presenters and to our audience for participating in this session. So we're now going to be moving into a brief 15-minute break. If you plan to attend session 5A, I believe it's in the Zoom link, Anthony. Okay, cool. Anthony, correct me if I'm wrong. But if you are wanting to attend session 5B, please exit the Zoom, go into FeedLoop, and you'll find the Zoom link there. So that's it for us. Have a great rest of your day too, and thank you so much for joining us.